Okay, so in this next tutorial, we're going to take a look at doing some surfacing on the lathe itself. So in this example, we're going to learn how to create a freeform feature and some 3D surfacing toolpaths as an introduction, using this on a lathe using a ball tool. So let's go ahead and get started. So the next example that we're going to look at, we just did the wrapped pocket here. We did these OD holes. The next thing that we're going to do is I'm going to rotate the part here so that we can see this next feature. This feature is comprised of 3 different solid faces, and this is basically, kind of like a mold. You're going to do some 3D toolpath on this, and we're going to use a ball mill. Now in my file I don't have a ball mill, so we're going to use this as an opportunity to set up another tool and go into that a little bit. So looking at the machine side, I'm going to rotate here. I can see all my tools, and I have not used this 4mm yet, so we're going to go ahead and change this out for something else. So we can change the tool, we can delete the tool and create a new one, whatever. What I'm going to do though is I'm going to show you something where you can basically right click on the adaptive, the clamping unit live tool item. And what I'm going to do is come down here to cut. And then I'm going to come down all the way to the bottom here. You can see unmounted elements. Maybe you noticed that. I can right click on that and say paste. And what that'll do is you can see now that that station is empty because I moved that entire assembly out of there. So now I can come in and right click and basically, because I might want to keep that, that tool assembly for later, and I might want to keep it in the file. So, you can do that very easily to set up, whatever you want on the turret. So we're going to go ahead and just kind of expand this a little bit. So what I'm going to do here is, I think I covered this, but you have your preview pane that if I hide that or bring it up, we can see the tool holder that we're selecting here in the preview window. Additionally, you can click the icon right next to that and change the look of how these icons are displayed for you. For me, because I work for Esprit, and we have a number of different, thousands of customers with lots of different machines. I don't have everything memorized and all these, tool holding and work holding products memorized. So I like to see the pictures. It's very helpful for me. So I'm going to pick this this Capto. This is a C3 Capto here unit from WTO. I'm just going to say open, and that appears on the turret. And again, it's based on the reference positions. We're not going to get into that. So I'm just going to say, OK to that, and then right click, and I'm going to say add another adaptive item because this is a Capto clamping unit. So I'm going to go back to the parent directory for WTO and look at what their adapters are. Now remember, it's a C3, so you can go to the Sandvik folder. You can go to, I guess ISCAR, like CamFix. They have a Capto CamFix type insert. I think that would work. I'm not too familiar with ISCAR, but I think that those are interchangeable. So, if we wanted a shrink fit, you can look at these and scroll through these. This is a C3, so we want to grab one of these here, depending on, these are the different sizes here. So you see like a 6mm. Well, we can try a 6mm. And remember, this can always be swapped out later. So you see that appears in the Capto pocket where it's supposed to be. I'm going to say OK to that. I'm going to right click, and then I'm going to say let's add a ball end mill. So once I select that, it's going to preview my tool, and we're going to say a 1/4 inch, 6mm, whatever. Maybe I'll just leave this alone to save some time. Yeah, we'll just do that. So it's pretty much the same. So you're going to want to set up, if you have a feature like this on your part, you're going to want to set up the tool that you want to use. It might not even be the same diameter that I'm choosing. So there it is, and we can see it in the turret in all of its glory. We're going to go back to the CAD portion, and now in this case, because we're doing a ball mill and we're looking at doing surfacing, we need to include the surfaces that we're going to machine into the feature. And we have underneath the feature tab, we have what's called a freeform feature. So there's 3 boxes here. One is part, check, and stock. So for the part, it's already highlighted. I'm just going to add the features that we want. And you can see that as I add them, they're added to the box, but also they're colored green. So like a stoplight, green means go, red means stop or don't touch it. So check, when I add the outside diameter as a check, we're basically telling Esprit we don't want to include that. Now, actually, I forgot to do something. I want my tool to come in straight from this direction. So trying to do thinking about too many things all at once. So what I'm going to do here is just change my work plane. And let's see if we have an existing work plane. This one is the opposite direction of this. So if you want to look at all this stuff, like there's one that's 180 degrees, this one will work. So the tool will come in along the blue vector, so it'll come straight down and machine this. But I'm going to show you, if I go back to XYZ, I'm going to show you a way that we can set that up very quickly. So under manipulation, under the drop down, you can select work plane from geometry. And if you select this icon, we can grab this flat surface at the bottom, and it will automatically create a work plane with a normal vector based off of the face that I selected because it's a flat surface. So here I can, if I could use the 180, but I'm going to go ahead and create my own. I'm just going to say 3D OD, work plane, whatever. So I'll say OK, 3D OD, and now I'll go to, the feature, freeform, and then I will add my 3. So on your file, you're going to want to make sure that you create that UVW in the correct direction so that your tool is coming down in the way that you want. Obviously in this machine, it's not a 5-axis machine, it's a lathe, so we want to do Y-axis machining with the tool from this direction. So I can call this a feature like OD 3D surface or pocket. And when I do that, it's going to be listed in my feature list. So again, just like any other operation, we're going to select the feature we want to apply the operation to, and then we're going to go to Freeform Operations this time. And now remember, the work plane is already built into the feature, so Esprit knows the tool is going to come down straight. So we can do a rough and then a finish. If this is aluminum, we might want to just do a finish. So it really depends on what it is that you want to do. In this case, I'm just going to do a finishing for right now. So what we're going to do here is come to this second icon, and there's a little arrow, and when I pick the arrow, we can pick different toolpath types. So you can see parallel planes finishing from the image that we're going to basically do a raster style machining across this surface, these 3 surfaces. So we're going to leave that called parallel planes. I'm going to come over here and I'm going to pick that tool that I had created at the end there. So we want to change up some of this stuff here. We're just going to go with some speeds and feeds. Tolerance value. You can go through all these. Do we want to leave any stock? We have independent wall and floor values. So do we want to optimize scallop height or by the diameter of the tool? We'll just say 3% is going to be okay for this particular operation. Start point, it's not super critical here. Again, going into the help, you can get a full explanation, but this is just helpful on determining, with the pass angle, they're relational. So I'll let you guys explore with that. But I'm going to go ahead and it's set to 180. So really, we only need to do either 0 through 90. So I'm going to start. This is our U vector that we can see here. I want to cut 90 degrees. I want to go back and forth this way. I guess it doesn't really matter. I'm going to put in 90. And we're going to, do we want a tangent pass extension, alternate cut direction? We're going to say yes. And minimum slope is going to be 0 through 90. We do not want to use that. We're just going to let it cut the green surfaces. Do I have a boundary? No. Looking at some of these things here, we can talk about the entry and exits very quickly. So when I click on one of these existing entries, it's going to give me an obvious description here. So radius and vertical plane, what is that? That's a vertical move that has a radius coming into the cut. What's vertical? Well, it's a vertical move straight down into the cut. But there's a plus sign here, so you can add multiple versions of this. So this, looking at this, like the arc angle, we'll make this like 90 degrees, and it's 25% of the diameter with a 100,000ths vertical distance. I can add the exact same lead-in type and move this, let's say, up to the top. And now we can see, hey, here's a 30-degree move, but my arc value is going to be almost the diameter of the tool with a 0.1 vertical distance. I'm going to put in a ramp angle of 0. So what it will do is Esprit will try to execute this as the entry move. If this doesn't work, it will try this next one. And then if that doesn't work, then it will resort to a vertical move as the last option. So I'm just going to go ahead and say OK. And Esprit calculates a toolpath. So we look at the toolpath on the screen and we can see that we're going 90 degrees, we're going back and forth the way that we wanted to, and we're getting that machining done. So at this point, if you wanted to maybe adjust something, like maybe this step over is pretty tight and I don't want it to be that tight, again, just like any other operation, you can go into the operation and come over here to any of the values that you've set before. So we're going to change this step over. I'm going to change it to something pretty big now. I'm going to go to 15 degrees and I'm going to say OK. And that's going to recalculate the toolpath to have a larger step. We can see some scallops now. It's not such a tight finish. It will save cycle time, but I sacrifice the finish. So what do we want to do here? Remember, we never did the finish pass on the OD, so that's why we see that extra, I think it was 10,000ths that we left on the OD there. So again, it's just a tutorial, guys. Let's not get too nitpicky. But we're going to look at this again in terms of the actual solid faces that are included. So one of the nice things about Esprit is I can go back to this freeform feature and say, hey, you know what? I really don't want to maybe do the two, fillets, or maybe actually we'll do something crazy. We'll make a donut-shaped toolpath that doesn't do, the inside. So if I were to just highlight that and delete that from there, or just maybe add it to the check surfaces, we can right-click on this, and here we can choose from a number of different things. I'm just going to go ahead and say rebuild that toolpath, and now we can see that that area is not machined, and we can see the stock indicates that for us visually. So you can have some flexibility with these toolpaths in the way that they are executed. So let's pretend that there's no stock here, and we wanted to pay attention to tool wear on a mold where here we can see it cutting and then it's going to cut along this side, then pick up, and then come in and cut along this side and rejoin that. Well, the tool wear between the end of this pass and the beginning of this pass is going to look different when you look across the surface. So if we wanted to just continue to go across but not machine this middle portion, that is what this rapid over is going to do. We can say yes, and that will rapid over this middle portion of the toolpath. Now, of course, we do have stock in this particular example, so it's not something that necessarily wanted to do for this. We would rough this out or whatever, but so you can play with those settings, look at the help file, and get a a good idea of how that toolpath can work for you depending on the surfaces that you want to machine.